So first of all, we're just going to recap what the derivative is. So the derivative tells us how rapidly something changes with respect to a parameter. So here, for example, we've got some function that depends on x, and we want to see how this function f of x changes as you go from x1 to x2. So geometrically speaking, it gives us the slope. So here we have df is equal to df over dx dx. And the df dx, the derivative, is essentially a proportionality factor. Now, suppose there is more than one variable in a function, and what we want to do now is to examine how that function varies with respect to just one of those variables, while we keep all the other variables constant. Now, this is what we have. What we have here is partial derivatives, and suppose we have some function f which depends on x and y, and this is equal to ax squared plus by squared. And what we want to do is determine how this function, which depends on x and y, how it's going to vary with respect to x and how it will vary with respect to y. So as I said, this is called this is partial derivatives. So we take the derivative of f with respect to x, and what we get here is 2ax. Now we can also look at how it varies with respect to y. So we take the derivative of f with respect to y, and what we get is 2by.